Looking at electrolytes at pH, and then we'll stop for today. We'll do the organic molecules next week. Electrolytes refers to charged particles dissolved in water or body fluids. They're called electrolytes because the solution can conduct electricity. You know how they tell you not to have electronic devices right by the tub? Because if it falls in, you can get shocked. And that's the water conducting the electricity because it has some ions dissolved in it. Three categories of electrolytes are acid, base, and salt. The difference is based on which ions are increased when the substance dissolved. An acid releases H+ or hydrogen ions. So hydrogen ions are the definition of acid, basically. A base causes an increase in hydroxide ions, written as OH-. When it dissolves, now sometimes it produces those, sometimes it snags the hydrogen out of the solution. So you can also look at it as acid has more hydrogen, base has less hydrogen. A salt releases some kind of other ions that doesn't affect the amount of hydrogen in the solution. Now here's how dissolving works. Say you stick a salt crystal in some water. At first, the sodium and the chloride are sticking to each other in this big cluster. But the water, being polar, can also attract the sodium and the chloride ions. So they pull the ions apart and spread them out within the water. You can think of this as a group of friends goes to a party where they don't know anybody else. So they decide, we're going to arrive together, we'll hang out together to start off. But then everybody else at the party, who would be the water, are really friendly. And they come up and they grab a sodium ion and say, hey, let's go dance. Or they grab a chloride ion and say, try the buffet. And pretty soon, the friends are all just mingled throughout the party. And that's what dissolving is like. They go from clustered together to evenly spread out within a mixture. There are a couple of definitions related to things dissolving. A solution is a mixture where one substance is dissolved in another, like salt water. The solvent is the substance that does the dissolving. Now, in the body and anything we're going to do in lab, the solvent is water. If you've heard the term solvent otherwise, it's usually used for things other than water that can dissolve something special like paint or pine sap or something else that you might want to dissolve to get it off. But water is really great at dissolving most things. The things that are dissolved in the solvent are called solutes. We'll talk about solutions and solutes. We'll almost never talk about solvents because it's almost always water. So a solution would be a mixture with lots of solvents and solutes scattered throughout it. So if anybody's drinking tea or coffee, you've got water as your solvent, and you've got tea flavors or coffee flavors, plus sugar if you put it in there, as solutes. pH is how we measure what portion of solutes in a solution are hydrogen ions. Now there's some weird math we do to get nice neat numbers called a logarithm that kind of flips things over. So the lower the number, the more hydrogen is in it. The lowest you can get is 0, which is maximum hydrogen. The highest you can get is 14, which is almost no hydrogen. Right in the middle at number 7 is called neutral. That means you have equal amounts of hydrogen and hydroxide ions. Now, what do you think might happen if those two came together? One's positive, one's negative, so they're going to attract.
Neutral.
Yep, they'll become neutral. Can you think of what specifically they'll become? Water. 2 hydrogens, 1 oxygen. You put an H and an OH together, you get water. And that's one of the products you would get in your exchange reaction. So at 7, pure water is a thing that's truly neutral. You can get other things that are neutral as long as what's dissolved in them isn't affecting the amount of hydrogen. Anything below 7 is acid. The lower the number, the stronger the acid, which means the bigger difference between how much hydrogen you have and how much hydroxide you have. The strongest acid is hydrochloric. That would have a pH of 0 if it were dissolved with nothing else. What that means is it completely breaks up into hydrogen and chloride ions. So you get as much hydrogen as possible from it. Other things that are acidic, stomach acid or gastric juice. Most fruits and vegetables are at least slightly acidic. We have a range from 3 to 6 here on a couple of different examples. Any number over 7 is basic, which means it has more hydroxide than it has hydrogen. The strongest base that would take us to a pH of 14 is sodium hydroxide. So it completely splits up into sodium and hydroxide, giving us as much hydroxide in the solution as possible. Bases in everyday use are cleaning products like ammonia or antacids like milk of magnesia or Tums tablets. Sodium bicarbonate, also known as baking soda, is a base. The way it works to make a cake rise is it interacts with an acid, and instead of hydroxide, the anion it releases turns into carbon dioxide, so it makes bubbles inside the solution. It's pretty neat. Now, here's our exchange reaction. We take this apart, we take this apart, we put them together in a different way. What do we get? Yep, so HCl plus NaOH becomes H2O plus NaCl. So you put the two toughest chemicals together in terms of pH in the right proportions, you get harmless salt water. There's a story that anyone remember from your American history classes, the Dewey versus Truman election? Everybody was so sure Dewey was going to win. You might know that he didn't, because you've never heard of a President Dewey, but you've heard of President Truman. There was a reporter at the time that said, if Truman wins this election, I'll eat my hat. And he said it publicly, and it was published. So Truman won, and he had to eat his hat. And the story goes that he had a chemist dissolve his hat in sodium hydroxide. One of the uses for sodium hydroxide is drain cleaner. It dissolves hair very well. And hats are made of something similar to hair. So he dissolved his hat in the sodium hydroxide, and then carefully balanced it with hydrochloric acid. And then the guy had this big tub of salt water with dissolved hat that he drank. Now, the importance of pH in the body. Normal blood pH is about 7.4. There's a little range around that that's considered healthy. So blood is not neutral, it's very slightly basic. If the pH gets too high or too low, true neutral would be too low, you get sick. The body has chemicals called buffers that can stabilize pH. The way they do it is they can either pick up or release hydrogen ions, depending what's around them. If there's extra hydrogen around it, they grab it and they raise the pH. If there's very little hydrogen around them, they can drop it and lower the pH. So buffers work to keep our blood pH right at 7.4. Right, so that's it for today. We'll pick up with the organic chemicals next time.